Question 2J from the homework is this question here. We're asked to find where the intervals of the curve are concave up or concave down and points of inflection. So basically we are talking about the second derivative. Now we can differentiate this using quotient rule as is. We also have the option of differentiating this as a rational function that looks like this, 1 over. We can split up the 1 in the x minus x squared, and we can write this as 1 over x cubed minus x squared over x cubed, which simplifies to 1 over x. And this may be a little bit easier. It's certainly not wrong to differentiate this with the quotient rule. It's not particularly difficult either, but I'm going to do it this way. So when I differentiate this, I'm going to end up with negative 3 over, and I reduce the power by 1, so I end up with x to the power negative 4, and so it ends up being x4 in the denominator. I'm going to differentiate the power negative 1, so this becomes positive. It becomes positive 1 over x squared. Differentiating this again to get the second derivative, I'm going to again apply the power negative 4, so now it becomes positive 12, and then x reduce the power by 1, so I get negative 5. This is going to be a negative 2 power, so I'm going to end up with minus 2, and then x to the power negative 3, so I get that. So I want to find out where the concavity changes occurs. Okay, so first of all, I know that when I do this problem, I have a restriction of x not equal to 0. So I have to be careful of that. So I'm going to have a point that I have to check there. And then I need to solve this equation equal to 0 to check for any 0 concavity points. Okay, so when I solve that, I'm going to end up with 12x5 is equal to 2x cubed, and then I divide both sides by 2, so I end up with 6x cubed is equal to x to the power 5. And again, I want to solve this equal to 0, so I end up with x to the power 5 minus 6x cubed. Factoring out the x cubed, so x squared minus 6. Okay, so I have a non-differentiable point there. I have in this case here, my x is equal to 0, but since it's not equal to 0, that's an extraneous solution. And then I have x equal to plus minus square root 6. So those are the points I'm going to test my concavity. So negative root 6 and positive root 6. So there's my 0 concavity here and here. Now at this point, I'm just going to test my derivative, my second derivative for concavity. So the second derivative, so I need to choose a point to the left of root 6. I'm going to choose negative 3. When I plug it into my derivative, I'm going to end up with 12 over negative 243. I should maybe plug that in. 12 over negative 243. It's going to be negative 3 to the power 5 minus 2 over negative 27. So this works out to be, this number here looks to be, it's hard to tell, so I'm going to use my calculator here. So I get negative 12 divided by 243 minus or plus 2 over 27. I end up with positive value. Okay, so it works out to be slightly positive. It's 0.02. So I end up with a positive concavity here. And so I need to test my concavity on these other points. So at negative 1, I'm going to plug in my value at negative 1. Plugging that in, I'm going to end up with negative 12 minus negative 2. So that's negative concavity there. And then at y prime, the second derivative at positive 1. Plugging that in, I end up with positive 12 minus 2. So that's going to give me again positive concavity. So I have positive concavity here. So here I have an inflection point so far at negative root 6, 0, and lastly I need to test for concavity at positive 3. When I plug in positive 3 in here, I'm going to end up with positive 12 over 243 minus 2 over 27, and then again that's going to give me a negative 0.02, slightly negative, but still negative. So there I have my concavity chart showing me inflection points at negative root 6, 0, and positive root 6.